So we are now looking at some applications with right triangles. So using right triangles to answer some questions. So I'm going to first start out with one of the easier problems. And this is just finding a distance across a pond. And so they really don't say anything in this problem, but usually you're going to read through again, you're going to read through again. It's helpful to make pictures a lot of times in these word problems. Sometimes they're given to you. In this case, this picture was already given to me. And so we're going to find the distance from A to C across the pond illustrated in the figure. Well, you guys can't see that figure, so you get to see my lovely drawing. And so we have some pond in here. And we have some point A. Oops. We have some point C right here. And we have some point B. And so with those 3 points, we're going to form a right triangle. And it was given that this was a right triangle. And they gave that the angle B, this is equal to 40 degrees. Okay, so they asked us to find this distance in here between A and C. So because I denoted this with capital letters, let's denote the sides by the lowercase. And so we want to find distance B. Okay. We also given that the distance between C and B, this was 100 feet. Okay, so when you're given these problems, again, you want to graph it. Somehow we're going to be able to form some right triangle with it, because that's all we've learned how to do. Or if not, we're going to be able to construct some right triangle in that. Think about the trig functions you know. Think about the angle you're given or that you can derive and use. So I have angle 40 degrees. And so let's look at the side. We have a side that is across from it, and we have a side that is adjacent to it. And so think about which trig function uses opposite and adjacent. So which trig function could you use that was opposite and adjacent?
Tangent? Oh, tangent, yeah.
Yeah, tangent. So I have tangent of 40 degrees. So this is opposite, which is side B, and adjacent, which is 100. Okay, so we've gotten everything we need to know now to find side B. So we can get B by itself by multiplying both sides by 100. And so we get B by itself, so we have 100 tangent of 40 degrees is equal to side B. So when I was reading through the section on this, they were talking about how they round sometimes, and using significant digits, they use 1 decimal place for angles to the tenths. And this book also uses significant digits for distance, sides, and they use to the hundredths. But my math lab, I'm sure, is going to tell you, maybe, hopefully, what it would want as homework in there on the test. So we haven't really talked about the calculator and putting that in. So in your calculator, and everybody has different calculators, and maybe between break I can pull up my math lab, But in our calculator, you need to make sure that you're either in degrees or radians. So in my case, I need to be in terms of degrees. So I want to make sure my calculator is in degrees or your answer is going to be different. And so I would just type in 100 times. This is a scientific calculator, so I have tangent in there. And again, it depends on your calculator, depends on how you would do that. If you put tangent first and then the angle, or if you put the angle and then tangent. But doing this, I get B is approximately 83.9 B. Oops, 91. I just said to the hundredths. So I'm rounding. I have a 9 in the thousandths place. The 9 rounds my hundredths up to a 1.
When would you know to put your calculator in radians versus degrees?
It depends on what's given in the problem. So in my problem, it was given that my angle was in degrees. It was 40 degrees. So if that had said that it was like pi 6, then I would have put it in terms of radians in my calculator, or I would have converted my radians into degrees before I put it in the calculator. But there should be a setting on the calculator. Mine is pretty easy. Let me see. Let me pause this for a second. Okay, so just wanted to make sure everything was going okay. Saw some chat in there about the recording. But anyways, that unfortunately is going to happen maybe because we're doing it this way. But let's try to work through it. And we have this problem. We finished it. There was a question was, what was given in the problem and basically, or what it was it asking. Basically, this problem gave us the figure. It gave us all the data with the picture. And it was asking for the distance between points A and C across the pond. And so we called that side B. They didn't actually label the sides as B, but I decided to call it that because it's across from angle B, which is with a capital. Okay, so let's look at one where we have to actually draw the picture. Is my screen being shared? Yes. Okay. So the following, I'm just going to read it through and then we'll go back and we'll start drawing a picture and pulling out the information. So it says a person in a small boat offshore from a vertical cliff known to be 100 feet in height takes a sighting of the top of the cliff. If the angle of elevation is found to be 30 degrees, how far offshore is the boat? Okay, well that just brought me to I need to tell you some definitions. Angle of elevation and angle of depression. So let's first do that before we actually figure out that problem. So if you have an angle of elevation or angle of depression, you'll always start this from the horizontal line. And for angle of elevation, from that horizontal line, you're going to go upwards. Which makes sense, right? Elevation is upwards. So angle of depression, depending on, they might say that you're looking this way. You always go from the horizontal line, but we're going to go downwards. There's other direction they might use, and that depends on where you're going to start. And so if they ever say you're going a bearing of, let's say X degrees, you're always going to start at the north. So a lot of times line, we'll put in our directions. So we're going to start at north. And go clockwise.
That says a bearing of X degree?
Yeah, so if it says a bearing of X degrees, you have to start at the north and go whatever X is. So before it was positive angles, we went counterclockwise and we would start at the standard position, which was the positive x-axis. But if it tells us in directions or in a word problem that maybe the ship was going at a bearing of 30 degrees, then I know that when I draw my picture, I'm going to start at the north line and I'm going to go clockwise the 30 degrees. One other way that I've seen that they've done direction is they're either going to start with north, south, they're going to give you an angle, and then they're going to give you either east or west. Okay, so another way that they might give you, they will start with north or south. An angle is given. And then south or west. Oh, I'm sorry, not south, east or west. And then ended with west or east. So for example, if it said go north 45 degrees west. So it's gonna have the initial it starts with the direction. So that tells me I'm starting on my north line. And I'm going my west direction 45 degrees. And so starting at the north, go 45 degrees. So another example could be if I had south 65 degrees east. So I would start at the south and I would head east direction, going 65 degrees. So just approximate. Where if it said there was a siding at an angle of elevation, of 9, let's say 85 degrees. So angle of elevation, start always at the horizontal, and then it's going 85 degrees. And so 85 degrees, almost 90. Elevation is upwards. if you went in, you headed at a bearing of 135 degrees. So it didn't say anything about north, south, east or west. And so I know I have to start at the north line when it says bearing, and I go clockwise. And so this is 90 degrees, about 135 degrees. Okay, so just some terminology that you might see in some of these problems. I actually have only seen, right, so far in your book is angle of elevation and angle of depression. But that doesn't mean that it's not going to come up later when we do more applications. And you could see it in other books. Okay, so going back to that problem, we're off the shore. We look up and we see a cliff. There's a cliff off the shore. And we know that this cliff is 100 feet tall. Actually in a sailboat. And from there it says, you take a siding to the top of the cliff and the angle of elevation is found to be 30 degrees. How far offshore is the boat? Okay, so from looking from the ship, that angle of elevation, and your height isn't that big, we should kind of just assume it here. So angle of elevation is 30 degrees. So that tells me I'm going upwards from the horizontal 30 degrees. And we wanted to find the distance to the shore. So maybe let's just call it X. Okay, so again, from an angle that we know it's a right triangle, so we can use our trigonometric functions. Right triangle, we have an opposite and we have an adjacent, so that should clue you in to use tangent. You could use cotangent, but that's much harder. So we have tangent of 30 degrees, and it's opposite, which is 100, all over adjacent, which is X. So we need to get X by itself. Well, let's first reduce. We should know what tangent of 30 is. Or if we don't know what tangent of 30 is, we should know what sine and cosine of 30 is. And so we could rewrite tangent in terms of sine and cosine. Tangent is sine of 30 degrees all over cosine of 30 degrees, which is equal to 100 all over X. Okay, so 30 degrees. Sine is below, that's 1. So this is a root 1 over 2, which is 1/2. All divided by cosine of 30 degrees, fingers above, that's 3 of them, root 3 over 2. Is equal to 100 over X. So really, if we have a fraction equal a fraction, we can use cross multiplication to solve. So 100 times.
Quick question, why did we divide sine by cosine?
Oh, I'm using the fact that tangent of theta could be expressed in terms of sine and cosine. So I would just
can't leave it as tan 30 equals 100 over X.
You could have, I'm just going through if this was something, if you didn't remember how to do the angle for tangent of 30, it could easily be derived by sine and cosine.
Okay.
But tangent of 30, anyone know what that is?
Square root 3 over 3?
Yeah. Where we would have gotten that if I kept it, if we looked at this and I didn't use my cross multiplication. This is, like I said, 1/2 divided by root 3 over 2. So this is the same thing as 1/2 times the reciprocal, 2 over root 3. 2's cancel. So we have 1 over root 3, which is root 3 over 3. So technically, for me, I know, again, and I think I mentioned this last week, is tangent. I know one of them is going to be root 3, and I know one of them is root 3 over 3. So 30 degrees has the 3 in it. It has the more 3's in the answer. I don't know if that helps. But again, if you know just your sine and cosine, if that, those are the ones for sure you have to have memorized, you can quickly, hopefully, derive the other trigonometric functions at those angles that we should have known. So you should be able to do this piece without using a calculator. Does that clarify or answer the question?
Yes, thank you very much.
So we're going to use cross multiplication to solve for x here. And so I can do that by saying 1/2 times x, or 1/2 x, is equal to root 3 over 2 times 100. Same thing as just clearing our fraction. 2 goes into 100, I notice, 50 times. And so I have 1/2 x is equal to, I'm going to just put the 50 in front of the root 3, 50 root 3. Get x by itself, I can multiply both sides by 2. And so I get x is equal to 100 root 3. Okay. So if they ask, so if I didn't allow you to have a calculator on this piece, you would leave it like this. Except that you would put your units. And we were talking about feet. We were given feet offshore was the distance of the, or the height of the cliff.
Would you have been able to solve it if you still used tangent 30 and gotten root 3 over 3, or would you say it's better to do sine over cosine?
Oh no, if you know tangent of 30 is root 3 over 3, that would have been much faster, because we would have gotten there root 3 over 3, just from this piece right here. This is equal to 100 over x. We could multiply both sides. So this is, well, maybe not. Root 3 times x is equal to 300. Divide both sides by root 3. So I get x equals 300 over root 3. Unfortunately, I have to rationalize the denominator. Maybe it's not faster. This is 300 times root 3. Well, square root of 3 times square root of 3 is 3. 3 goes into 300 100 times. So either way, we're going to get the same results.
So it's kind of simpler.
Oh, yeah. Yeah, I'm just using the definition that tangent could be rewritten in the form of sine over cosine. So knowing one of the trigonometric functions like that is so much faster than having to rewrite it. Okay, so any other questions on that?
Could you zoom out a little bit so I can?
Zoom out like this. Sorry, that's, yeah. Do you want which piece?
Okay, yeah, I got it.
I was thinking that maybe it would be easier if I typed some of this stuff in, and that's why my screen is it's elongated this way today, and I haven't even typed anything in here. So maybe I'll change it. Let me just change it. One nice thing about it being elongated that way is I have access to, it's easier. Okay, so finding the reach of a ladder. A 22-foot extension ladder leaning against a building makes a 70-degree angle with the ground. How far up the building does the ladder touch? Okay, so we have some building. And we have some ladder. We're given that this ladder is 22 feet. And we're given that the angle between the ground and the ladder is 70 degrees. Makes a 70-degree angle with the ground. How far up the ladder does, how far up the building does the ladder go? Okay, so again, figure out what you're trying to find, what side. And so looking at it, we're trying to find this length, how far up the building. Let's just call it some variable. I'm just gonna call it Y. And then notice from the angle, it's a right triangle, the side that you're trying to find and what you're given. So here, we're trying to find the opposite, and we're given the hypotenuse. So opposite and hypotenuse from angles 70, which trig function would you use?
Sine.
Which one?
Sine.
So sine is opposite over hypotenuse. So we can say sine of 70 degrees is equal to the opposite, which is y, all over the hypotenuse, which is 22. And so we can get y by itself by just multiplying both sides of our equation by 22. And so 22 times sine of 70 degrees. And we're in terms of degrees, make sure. And so we get y is equal to 20. And it told me to round to the nearest hundredth. So I have 0.673. 3 tells me to keep the hundredths position the same as it was given 6.7. You know what? I'm going to put an approximate sign just to notate I rounded. And we're in terms of feet.
We do have a dress code. If you have someone non-athletic. But that white kid out there in hat, he's kind of shoes boy, and his athletic shirt.
Hold on. How did you get the 20.67?
So I multiplied, so right here, I multiplied both sides by 22. So I got y was equal to 22 times sine of 70 degrees. 70 degrees is not one of the angles that we know, and so I had to use my calculator. And I knew to use sine because of the ratio of sides that I was given and what I was trying to find.
Excuse me, Professor.
Mhm.
So, on problems like this, are we going to be able to use our calculators or no?
So if I didn't allow you to use your calculator, then I would say, just give me the exact number or exact form, and this is how you would leave it.
Okay.
If I allowed you to use the calculator, then you would answer it like this. Which makes more sense, I mean, if we're thinking about something. If someone told me that, oh, the ladder was 22 times sine 70 degrees feet up the building, I'd kind of look at you funny, right? You probably look at them funny too, right? That doesn't really give you much information, but approximately 20.67 feet definitely makes more sense. Okay, so now we're going on a hot air balloon ride. You guys ready? So while taking a ride in a hot air balloon in Napa Valley, you wonder how high you are. So to find out, you choose a landmark that is to the east of the balloon and measure the angle of depression to be 54 degrees. A few minutes later, after traveling 100 feet east, the angle of depression to the same landmark is determined to be 61 degrees. Use the information to determine the height of the balloon. Okay, so we're on a balloon. And from the balloon, we notice a landmark. And the landmark, it told me, was to the east. And so the angle of depression, well, it's always angle of elevation or depression is from the horizontal. You see a landmark that is 54 degrees. So depression goes down 54 degrees. And you travel a little further, and you travel, I think it said 100 feet. So after traveling 100 feet east, look at the angle of elevation again, but this time it was 61 degrees. So in order for that to happen, I'm going to change my picture a little bit so that my building's a little more up closer. And we're trying to find the height. Oops. That doesn't make sense. Hold on. I should have probably waited for my building. So this is 54 degrees. This is 61 degrees. Here's our, and we want to find the height. And I'm going to change this a little bit. Okay. So we need to figure out some stuff. We need to figure out, let's see. So this right here is a horizontal line. This right here is a vertical line. So we know this angle with our 54 degrees and this line right here, this has to sum to 90 degrees. So we know this angle in here has to be a 90-degree angle. So a 90-degree angle minus our 54-degree angle, that gives me 36 degrees. Not drawn to scale. So angle of depression here was 61 degrees. We know for a, let's see, this is 36. Yeah. Let's form another triangle in here. Okay, so we don't know how far this is, and we're trying to figure out what this is. Maybe we can call this length X right now. And maybe we can call this length the height Y. Okay. I don't like my picture very well. Basically, we have kind of, we can form this as a rectangle. I'm still not doing a very good job. We called this X, we are calling this Y. We know that this angle in here is 36 degrees, and we know this angle in here is 54 degrees. We know that this angle in here is 61 degrees. And anything else we know? We're trying to find out what Y is. So I think there's multiple probably ways that we can approach this. And I can't cover up my page with you seeing what I'm covering up. So let's look at our 54 degrees. Let's look at this triangle in here. This right here, I think we can do. So if we're from 36 degrees, we have opposite, and we know adjacent. And so tangent uses the 30 degrees, and tangent uses opposite and adjacent. So we have tangent of 36 degrees. This is equal to the opposite, which is 100 plus x, over the adjacent of 36 degrees, which is y. we'll come back to that equation in a minute. So we have another equation here. We have this other triangle in here. And we have X right here, and we have Y right here. And so looking from 61 degrees, we have the opposite and the adjacent. And so opposite and adjacent, again, we're going to use tangent. So we have tangent of 61 degrees is equal to the opposite of 61, which is Y, over the adjacent. So basically, we have two separate equations and two unknowns. So we can use substitution. We could solve for Y in each one of these, or I can solve for X. Doesn't matter. Let's solve for X, because really, if I solve for X and I replace what X is, I'm really trying to find that distance Y. So, doesn't matter. In the end, we could find the same result if we solved for Y. So let's solve for X. One of the equations. So I'm just going to choose the first equation. So I notice I can solve for X if I multiply both sides of the equation by Y. Let's multiply by Y on both sides to get X by itself. And so if we do that, we get Y times tangent of 36 degrees. Is equal to 100 plus X. The point was to get rid of the Y in that denominator. And so I almost have X by itself. I can get X by itself by subtracting 100 on both sides of the equation. And so I get that X is equal to Y tangent of 36 degrees minus X. I'm sorry, minus 100. Okay, so we're going to use substitution. So we're going to go back in here where we see X. We're going to replace it with what this is. And so I have tangent of 61 degrees is equal to Y divided by X. The X we said was Y tangent of 36 degrees minus 100. Solve for Y. So again, we have an equation, we want to clear a fraction, so we can multiply both sides of our equation by our denominator, Y tangent of 36 degrees minus 100. So I have tangent of 61 degrees, all times my denominator, Y tangent of 36 degrees minus 100 is equal to, well, when I multiplied this side by my denominator, it would have canceled, just leaving me with Y. So we're trying to solve for Y. We want to get Y by itself. So I notice I have technically two terms in here with Y. Let me distribute my tangent of 61 degrees to both of those terms inside the parentheses. And so doing that, we get Y is equal to, we get Y tangent of 61
degrees. All times tangent of 36 degrees. Minus 100, distributing the tangent is 61 degrees. Tangent is 61 degrees is equal to y. So it's technically like a linear equation. I have y is just raised to the first power, so I want all the terms with y in it to one side of the equation, and any other piece that doesn't have y in it remain isolated. So let's subtract this y tangent of 61 degrees times tangent of 36 degrees on both sides. I'm just going to write this on the left now, though. So I have y minus, subtracting this piece. So y times tangent of 61 degrees is equal to negative 100 tangent of 61. So I have two terms with y in it. We could factor that y outside. And so if we pull the y out from those two terms, we're left with a 1 from the first term, minus, and we're left with tangent of 61 degrees times tangent of 36 degrees equals negative 100 tangent of 61. We're almost there. We need to get y by itself. Now we can do it. We have this as just one grouping with y. And so we can divide both sides by that big parentheses. And so we get y is equal to negative 100 tangent 61 degrees all over 1 minus tangent 61 degrees times tangent of 36 degrees. Careful when you're plugging this in the calculator, where you place parentheses are very important, or it's not going to calculate it right. And so we need parentheses. Think of it as our whole numerator, negative 100 times tangent of 61. I'm going to close my parentheses for my angle and my numerator. Divide by parentheses for my denominator, 1 minus tangent of 61. Close my angle times tangent of 36. Make sure my angle is closed in my denominator. And push enter. I did this right. I get y is approximately 580.61. I believe we are in terms of feet. I would have known something was wrong if I had gotten a negative answer in here. That to me kind of seems realistic. My picture might not be the best in depicting it.
Excuse me,
I
Professor.
could go back in and I could figure out what x is. That's not what the question asked, but if I wanted to figure out the distance of what x is, maybe how much further I have from where the hot air balloon was from the second siding to where the top of the landmark was, I could figure that out by plugging in 580 into this piece. And that would give me the distance of x. Okay, so sometimes when drawing these pictures, they get a little bit complicated. You've got to sometimes use some information from geometry to help you. Like we know that
If you have a 90-degree angle and you're given one angle, then we can figure out what the other piece is. I did that to figure out what one of the angle was so I could make a right triangle in there and use trig. Okay, so I'm going to do, what time is it? Let me do, or at least let's set up one more. Okay, so they're constructing a highway, and the highway generally goes from north to south. It's being constructed along the west coast of Florida. Near Naples, I don't know if that's how they pronounce it, a bay obtained the straight path of the road. A bay obstructs the straight path of the road. Since the cost of the bridge is prohibitive, engineers decide to go around the bay. The figure shown shows the path that they decide on and the measurements taken. What is the length of the highway needed to go around the bay? Okay, so there's a bay that, a bridge, there's a highway being built. There's this bay in the middle from going north to south, and they need to go around it. And you're actually given a picture, so that's kind of helpful. Okay, so this is the road they're going to take. And we're given some angles. We're given that the angle, the left angle between the road and north-south, which doesn't look north-south in the picture, is 140 degrees. We're given that this angle in here is 130 degrees. We're given the length of the bay, or between the roads here. This right here is given to be 3 miles. And we're given that this distance in here is 1 mile. What is the length of the highway?
Excuse me, Professor.
Mhm.
I believe there's something wrong with the audio. We're all having problems. It's kind of muffled. I thought I was the only one. I thought it was just my connection. I didn't say anything, but it seems that I'm not the only one.
Okay, so let's just pause here for a minute, and let's try to figure out what's going on or try to fix it.